Hello, everyone. How are you today? Today, we're going to start to factor quadratic expressions. So, in our last unit, we learned how to multiply x plus 3 times x minus 4. So, I would like you to pause right now and do that problem. So when you do that problem, we do that by double distributing. So we get x squared minus 4x plus 3x minus 12. And then we combine our like terms, and we x squared minus 1x minus 12. So why that was important is what we're going to do today is we're going to learn how to go backwards. So I'm going to give you the trinomial, and you're going to figure out the two binomials that multiplied. So this is in the form ax squared plus bx plus c, where a is always the number in front of x squared, b is in front of x, and c is always our constant. Now, today's lesson, we're focusing only when a is 1, meaning the coefficient of x squared is 1. So when we are factoring these, what we're looking for is we're looking for two integers, which I called m and p, whose product is equal to c, whose sum is b. So if we look back at our example, I would be looking at two numbers that multiply to be negative 12, but add to be negative 1. And those two numbers would be negative 4 and positive 3, which you can see are the second part of my binomials. So that's what we're doing. We're going backwards. So for number 1 in our example, it's x squared plus 7x plus 10. So I want numbers that multiply to be 10, but add to be 7. So how we can start that is we can think about what multiplies to be 10. Well, 1 and 10, 2 and 5. Or we could do negative 1 and negative 10, negative 2 and negative 5. Well, 1 plus 10 is 11. 5 plus 2 is 7. So that is our pair. We know we want them both to be positive because these are both positive. So that factored is x plus 2 times x plus 5. Now you should always get factoring problems correct because you should be able to double distribute and check. So if we remultiply this, we get x squared plus 5x plus 2x plus 10. Now again, this purple part is the check. It's not actually our problem. Our answer is just the x squared plus 5, x plus 2 times x plus 5. I misspoke. So now we're going to do a next one. So here I want numbers that multiply to be 7, but add to be negative 8. So numbers that multiply to be 7 are 1 and 7, negative 1 and negative 7. When I add 1 and 7 equal 8, negative 1, negative 7 equals negative 8. So that is our choice. So it's x minus 1 times x minus 7. Here, they become a little more challenging when we have a negative that we want to multiply. So we want to multiply to be negative 16, but add to be positive 6. So what multiplies to be negative 16? Well, we have negative 1 and 16, 1 and 16, negative 2 and 8, positive 2, negative 8. Here I'm at a negative 1. Then we have negative 4 and 4. If we switch the signs, it really doesn't matter. So now we are looking for what they add. So if we do negative 1 plus 16, we get 15. 1 plus negative 16 is negative 15. Negative 2 plus 8 is positive 6. 2 plus negative 8 is negative 6. And negative 4 and 4 is 0. So our winning pair is the negative 2 and positive 8. So that's x minus 2 times x plus 8. Last example, we want numbers that multiply to be negative 56 v squared and add to be negative 1 mv. Now the v squared and the mv are taken care of by the fact that we have m squared and v squared and then mv in the middle. So we really don't need to do anything with that when we're doing our factors. That just comes about in that when we do our pairs, we have mv, mv. We have both ends. Here we've always done x and x. So numbers that multiply to be negative 56 add to be negative 1. We have negative 8 and 7 or negative 7 and 8. The pair I want is negative 8 and 7. So it's m minus 8v and m plus 7v. So let's have you try 1 through 3. So pause and try 1 through 3 and come back. Okay, so number 1, I'm looking for numbers that multiply to be 3, but add to be 4. So that would be 1 and 3. So that factored is x plus 1, x plus 3. Number 2, I'm looking for numbers that multiply to be 32, but add to be 12. So that would be 8 and 4. So that m this time, so that means it's m times m plus 8 plus 4. Here we have r squared, so that's r and r. We want numbers that multiply to be 2, but add to be negative 3. So that would be negative 2 and negative 1. So it's r minus 2 and r minus 1. The order doesn't really matter. It could be r minus 1 times r minus 2 because multiplication is commutative. So let's have you pause again and try the next 6. Okay, so again, I want multiplies to be negative 6, adds to be negative 1. So that's negative 3 and positive 2. If you can't think of it, make a list. X squared breaks up into x minus 3, and then it's x plus 2. Multiplies to be negative 21, adds to be negative 4. So that would be negative 7 and positive 3. So x squared is x and x. So it's minus 7 plus 3. Multiplies to be 121, adds to be negative 22. So 121 is really only 11 and 11. I want negative 22, so that's negative 11, negative 11. So it's x minus 11 times x minus 11, or you could write that as x minus 11 squared. Hopefully you're noticing a pattern that when my C is positive, my signs are the same. They're the same as the middle. When C is negative, my signs are different. So let's add that. C is positive, sign same as B. C is negative, signs are different. So here we want multiply to be 5, add to be 6. So 5 is only 1 and 5. So that's x plus 1, x plus 5. multiply to be negative 9, add to be 8. So that's a plus 9, a minus 1. And I know it's going to be plus 9 because I want 8 to be positive. So 9 plus negative 1 is positive 8. Multiply to be negative 8, add to be negative 7. So that's y minus 8, y plus 1. Okay, so I want you to do the last 6 and come back and check those. Okay, so number 10 should be x plus 2 times x plus 10. 11, a minus 2 times a minus 12. 12, y plus 9 times y plus 2. 13, x plus y times x plus y. 14, a minus 2b times a minus 2b. And 15, x plus 7y times x minus 7y. So that is the end of our video for today. If you have any questions, please ask me tomorrow in class.